Every task you do in life, every action you take is in some part mediated by motivation. How motivated are you to do the action or to do the task? And it's likely that some of that motivation comes at least in part from how much you think you'll be rewarded for doing that task. Or conversely, it might also be influenced by you not being punished, not experiencing pain, or some other kind of aversive state. In this level 2 intermediate video, we will be talking about the neurotransmitter dopamine and how it is involved in motivation and reward through something called prediction error signaling. If you want an introduction to dopamine, its relation to schizophrenia, and with a special emphasis on the two different types of dopamine receptors, check out the previous video in this series on those topics. Now, that being said, this current video is part of a mini-series on dopamine, which is actually part of a larger ongoing series on an introduction to neuroscience. But in this dopamine mini-series, we'll be talking about this neurotransmitter dopamine and the various systems that it's involved with. We started out, as I said, in the last set of videos, talking about the two different families of receptors that bind to dopamine and their relation to schizophrenia. So if you're interested, check that out. I also give a little bit of an introduction to the molecule dopamine, so that would be good to watch before this video. However, it's not completely essential. Now, this video is going to be talking about, as I said, reward and motivation. And in the next couple of videos, maybe one more video, maybe two more, and we'll be talking about addiction and as well as movement, because these are two areas in which dopamine is essential. So anyway, if you're interested in any of that, definitely check out our videos on dopamine. Now, as I said, this is part of a larger ongoing Introduction to Neuroscience series. We started out talking about the individual neuron, and then we moved up to how a neuron fires, how neurons become connected through synapses. We also talked about a couple other neurotransmitter systems, namely glutamate and GABA, and now we're moving on to dopamine. So we'll be talking about more neurotransmitter systems, and we'll be moving up and talking about brain systems, behavior. So now that we've kind of reached the neurotransmitter system point in this series, we won't be talking so much about molecular biology. We'll be talking more about brain systems and behavior. Now, with every topic in the Introduction to Neuroscience series, we will have three different levels of difficulty and length. So we'll have a level 1 beginner, which is basically just a 30 to 60 second kind of overview, summary of the main points of the topic that we're covering. Then we'll have a level 2 intermediate difficulty, and it will also be intermediate in length. It'll be about 10 to 20 minutes. And that will be more about giving you a little more detail, but not getting too technical, avoiding some of the kind of nuances. And we will have a level 3, longer, more advanced video, which will go more into depth, and it may cover more topics within the topic that we're covering. All right, so without further ado, let's get back to dopamine, motivation, and reward. By the way, I'm Andrew, and this is Sense of Mind. This channel is all about giving you the tools so that you can understand your brain, upgrade your mind, and improve your life. So we're all about doing both videos like this and this series on neuroscience, which is kind of giving you fundamental science knowledge about how the brain works and how the mind works. And we also talk about topics like mental health and critical thinking. So all around trying to give you an understanding of your brain and mind and how to improve it. So if you don't want to miss any future videos or anything, make sure to subscribe if you're on YouTube or follow if you're on Instagram. Definitely like this video if you get anything out of it, and throw me a comment below if you have any thoughts. I'm interested in what you have to say. And if you feel like it, please share this video with anybody who you think would benefit. Finally, we are finally launching our newsletter. So this newsletter is going to have exclusive content. We're going to have early access to content, and that will be for newsletter subscribers only. So definitely check that out. The link is in my bio if you're on Instagram, or in the caption below this video on YouTube. So thank you so much for watching. Let's get into it. Okay, so before we get into all this, let's do some definitions. So what is motivation, or better yet, what is a motivational state? So a motivational state is a kind of brain state or cognitive state that either leads an animal to seek a reward or to avoid some kind of pain or otherwise aversive stimuli. So motivational states come about due to both internal and external factors. Internal factors would be things like the state of the body, physiology, if there's perhaps stress hormones floating around, if the body is experiencing pain, or if it's hot or cold, if you're hungry, if you're thirsty, tired. These are all kind of internal bodily / cognitive states. And then it's also, of course, influenced by external stimuli. So this is kind of more what we think of when we think of reward and punishment, because, if you're motivated to seek a reward, it's, probably because there's something in your environment that would be rewarding if you were to get it. So, you see a cookie on the counter, and you're suddenly motivated to get up, walk over, pick up that cookie and eat it. So that might be an interplay between internal physiological and cognitive factors, such as your hunger, your level of willpower to keep yourself from breaking your diet, and as well as, of course, the external stimuli being the cookie itself sitting there. So there's a lot going on, but anyway, I hope that clarifies what a motivational state is. All right, and this may be obvious, but let's just define what a reward is. So in neuroscience and psychology, a reward is typically any kind of desirable object or action or other kind of stimuli, and it typically drives approach behavior. So typically drives animals, including us humans, to approach the object or do the action or get closer to the stimuli. And now these can be both short-term, like I was just talking about with the cookie being a short-term reward for getting up, walking over, and it can be also very long-term. Like when we think about completing a project, a long-term project at work, or getting a promotion or moving up in some way that requires kind of a long sequence of actions with this end goal, this reward far in the future. All of this, I want you to keep in mind throughout what we're talking about, that while we'll be talking about people and things that humans do, this is a system that is very important for all animals. It is especially for mammals, and we will see that throughout. So let's get back into this. So some of the important brain regions that are involved in reward and motivation are the nucleus accumbens, the ventral pallidum, the olfactory tubercle, the ventral striatum, the ventral tegmental area. And then there's other important areas that aren't strictly speaking part of this reward and motivation network, but are heavily involved in these processes, including the thalamus, the cortex, especially the prefrontal cortex, as well as the hippocampus and the amygdala. So there's a lot of brain regions involved, and we are going to be mainly focusing on those first ones that I mentioned, especially the nucleus accumbens. Okay. So there is kind of a common misconception out there that dopamine is all about pleasure, that it just causes pleasure in the brain, and that is not true. Now, it's true that dopamine is highly involved in the processes that eventually bring pleasure to conscious awareness. That is, it is involved in the generation of pleasure that you eventually perceive and feel, right? But dopamine is not causing pleasure wherever it goes, if that makes sense. Dopamine is involved in a lot of other functions other than just pleasure. And in fact, it's thought that dopamine is more involved in something called prediction error signaling. And so this actually characterizes dopamine's relationship to reward a lot better than if it were simply coding for pleasure. So I know that was kind of a lot, but let's look at how that works. We're going to break it down step by step and think about this. All right, so what we've got pictured here is a brain, your brain, and there are a number of regions highlighted. And so you can see the nucleus accumbens, the olfactory tubercle, the ventral pallidum. I could have probably also included the ventral tegmental area and the substantia nigra and some others. But regardless, it is this sort of area of the brain where we find these regions that are highly involved in motivation and reward. I want to talk about how prediction error signaling works. So what you're seeing here is on the left, we have an electrode placed into this area of the brain, this sort of reward network, this reward system of the brain, and we're recording activity from dopaminergic neurons. So that means that when these neurons fire, when dopamine utilizing neurons fire, we are going to see activity, and we're going to be able to record that and see it on the screen. So what you're seeing on the right is that activity. It's just a kind of baseline. This is what's called the tonic dopamine release. Dopamine is sort of just being constantly released at a baseline rate. And that is what we're going to be looking at, is the rate of firing of these neurons. So kind of how much dopamine is being released, how much activity is going on in these regions as far as dopamine is concerned. Okay, so now what happens? Let's think about, what if you get an unexpected reward? What does that do? Okay, well, you get this unexpected reward and boom, you get a spike in dopaminergic activity. You get a spike in these dopamine neurons firing. Their firing rate increases in response to that unexpected reward. And so by right now, you're probably thinking, well, that really seems like dopamine is coding for pleasure. I mean, after all, it happened right when you got the reward. You know, what else would you expect from something that is, showing, when you experience pleasure? Well, here's one reason why scientists don't believe that is the main function of dopamine here. So you have this unexpected reward. Let's say that this is a friend walking up to you out of the blue and giving you a cookie, right? And this friend just, didn't say anything about it before, brings you a cookie, and oh, that's so nice. You get that blip of dopamine activity, right? That burst. Okay. But let's say your friend does this for, a few days, and you start getting used to this routine. This friend is a great friend, right? They're coming every single day, bringing you a cookie, and you come to expect that. And in fact, what happens in your brain is when you see that friend and oh, okay, they're bringing the cookie. You see that, and that's when the dopamine burst happens. So that's what we're seeing in this image, is the cue is your friend walking up to you with that cookie. You get that blip, that big spike of dopamine, and then the firing goes back down to the baseline, even when you get the reward. So I said that dopamine is all about prediction error signaling. So what does that mean? Well, right here in this image, you are making a prediction, right? Your brain is predicting by that dopamine release, or that's what telling us that it's making a prediction, but your brain is predicting, your reward system is predicting that you are going to receive a reward. So it is releasing dopamine, it's saying, oh, we're about to get a reward in just a second, and you get it, right? And it just, things keep going, everything's fine. So what happens if you are expecting the reward, right? You see your friend coming, right? And you're like, ooh, cookie, cookie. You get that. That's the cue, right? So you get that burst of dopamine activity, right? But it turns out friend's out of cookies today, and she's upset. I'm sorry, don't have the cookies. And you're like, damn. And what happens then? Well, at the time when you would normally get the reward, let's say it's, the moment after your friend greets you, she usually gives you the cookie, you take a bite. But this time she greets you, no cookie, right? And then explains what happened, where she ran out of flour, couldn't make the cookies. But at that moment when you should be eating the cookie and experiencing that delicious chocolatey reward, your dopamine activity goes down. It actually pauses. So it's not just that it returns to baseline, it actually goes down. And so that is what tells scientists that, okay, there's something going on here with predicting rewards, right? So your brain is predicting that it's going to get a reward, but it doesn't. And instead of just returning to a baseline level of activity, it actually stops that dopamine signaling for a little bit, right? And so that's that system's way of saying you didn't receive the reward. We had an error in prediction. So that's what we mean by prediction error. So it is signaling the fact that you were wrong about your prediction. Okay, now the last situation is, if you had been receiving the reward for a long time, right? Your friend this was years, you guys are meeting up every single day. She's bringing a cookie, you're eating it, and this just goes on and on and on and on and on to the point that the cookie is just kind of boring at this point. You're like, all right, I don't even, I like it, but it's not that exciting anymore. And what happens then is your brain has completely learned, is completely habituated to this pattern, and it no longer is even worried about predicting that reward because there's just nothing more to learn about that situation. And that is something about dopamine, that it is actually really important for learning about rewards and punishment, about different kinds of stimuli in the environment. Some scientists interpret this as the brain saying there's nothing more to learn, right? We know this is here. We don't need to be changing dopamine activity. You might still get a little blip when you see your friend because that prediction is still there and it goes gradually over time. So you probably still get that. But, on the whole, it's really old hat. You're used to this now. It's like, when you first started driving a car, right, it was probably really exciting and novel, and it was fun to do it, to drive to, maybe you're driving to school or something. And then as time goes on, you get years and years and years of commuting and getting in the car. It's like, it's not at all a reward anymore. It's not even fun or exciting. So it's kind of, this is one way that we can see how our brains begin to habituate, begin to become really acclimated and used to the kinds of rewards that we usually see in our environment, or the kinds of things that we usually encounter. I hope that cleared up how dopamine is involved in reward and motivation. And we're going to get even deeper into this kind of stuff when we talk about addiction, drugs of abuse like cocaine and amphetamines, as well as opioids like morphine. We'll be getting into how those are related to the system that we just talked about, how addiction occurs, and this will lead us to talking about behavioral addictions. This will really allow you to understand a lot more about human behavior and how the brain mediates it. So I really hope that you got something out of this. And if you did, please throw this video a like. If you have any questions or comments, or you notice I got anything wrong, which is possible, give me a comment below. I'm really excited to keep this conversation going. Thank you so much for watching. Again, please make sure to subscribe if you're on YouTube, or follow if you're on Instagram, and share this if you know anybody who you think might get anything out of it. And finally, thank you so much for watching. This channel is brought to you by the Diamond Mind Foundation. This video was written and produced by me, Andrew Cooper Sansone. Thank you so much for watching. I'll catch you next time.